Okay, everyone, let's take a look at using our calculator to answer some of the questions from that lesson for Chapter 8. So if you worked through Chapter 8 fine and you've got everything you need in the calculator, then you probably don't need this. If you're trying to find stuff in Bell, or if Bell has been deleted from your calculator for some reason, then hopefully these should help. This is example number 4. It says we're using Bell to find the critical values for C equals 95%, and so on. We're still in 8.1 here. So these are Z values. This is question number 4. So we're going to go into the programs. We're going to launch Bell. So there's Bell. And we know the probability for that first example. It's 95%. Z equals 95%. So we know the probability. So we're going to enter a 1. We're interested in finding the boundaries. Now this is normal, right? This is 8.1. So we're talking about z-scores. So again, because we're talking about z-scores, we're going to enter a 1. Probability 0.95. And of course, we're interested in the inside area. We're trying to capture 95% of that probability with an interval. And there's our z-score, 1.959963986. Notice that in the notes in the lesson, the video that I made, I rounded that to 1.96, which is, I think, the same as in the table. Now, you can find this another way if you don't have Bell installed. You can go into the distribution menu, and you can go down to an inverse normal distribution. Inverse because we're trying to find the boundaries. We don't have them. So our area is 0.95. This is a z-score, so z, if it's z, then the mean is 0 and the standard deviation is 1. And then, of course, we're interested in that interval, that centered about the mean, so that's no great surprise. We're going to use the center. Now we're going to paste that in. So we're going to use inverse norm, and we'll get exactly the same thing. There's that 1.96 approximately. Okay, so we're now looking at example 5, a 1 proportion z interval. I'm going to go to the stat menu, over to tests, and then I go down to A, where a 1 proportion z interval is found. There were 125 successes, n was 500, confidence level was 90%. We calculate that. And there's our z interval. Okay, so we're now looking at example 6. Notice this doesn't give us the number of successes, but that's fine. It tells us that 68% of the sample is successes. So we enter 68% and we multiply that by the total sample size. In this case is 159. That gives us about 108 successes. We're going to use 108 as x. So I'm going to go into the stat menu, and I'm going to go over to tests. I'm going to go down to a 1 proportion z interval. There it is. And I'm going to enter 108 as my number of successes. 159 is the sample size. And it looks like we're constructing a 95% confidence interval. We're going to calculate that. So there is our confidence interval for the true population proportion. Okay, we're now at 8.3, and we're looking at example 7 from the lesson. We're asked to find the critical value, P sub C, when C is 90%. And we've got a random sample of size 350. So, of course, we're going to do this with Bell first, just because it's so easy. We've got the probability, and we want to find the boundaries. We enter a 1. This is a t-test. We don't know the population standard deviation. The degree of freedom is 1 less than n. So 350 minus 1 is 349. We're interested in finding the t-value, so we enter a 1. We are told that the confidence level is 90%, so we enter 0.9. This is an inside area that we're trying to find that interval that bounds it around the mean, so that's a 2. And there's our t, 1.6492335. And in the video lesson, I rounded that to 1.649. Now we can also do this without using Bell. So for those of you who have no longer have Bell on your calculators, we're going to go into distributions. We're going to go down to an inverse t-test. Now, what's interesting here is you can't enter C. This is like a cumulative probability, so it's got the left tail on it and it's got the middle on it. Now, for that reason, because it's got one of the tails and the entire central area, it's C, which is 90%, and half of the complement of C. The complement of C, that is what's left, is 10%, but we're only interested in the left tail, adding that, so that's 5%. 90% and 5% is 95%. So if you use the inverse t function in your calculator, make sure that you enter C plus half of the complement of C. So in this case, that's 95%. The degrees of freedom is still 349. We're going to paste that into our function, and out comes that same value for t. Okay, we're still in 8.3. We're now talking about examples 8 and 9. Yes, the same question, but just using different calculator functions to get there. So in the first case, we're going to use Bell. So I'm going to go to Programs, and I'm going to launch Bell. So there's Bell launched. We're interested in finding a confidence interval. That is, we're interested in finding the boundaries. We know the probability. Our confidence level is 95%. So we're going to enter a 1. This is a t-test because we do not have the population standard deviation. The degrees of freedom, the sample size was 29, so 1 less is our degree of freedom, 28. We're interested in finding our x values, that is actually in terms of the units, so we're going to enter a 0 for that. Now that means we've got the mean, and this is the sample mean. The sample mean x bar is 56. Now the sample standard deviation, remember we've got to use that formula that makes it behave like the standard deviation of the sample means. So that's 8.6 divided by, and let's go grab the square root of n. And in this case, n is 29. Close those parentheses. So that is a really cool function. It allows you to enter an expression into that field for the standard deviation. And then the probability, our confidence level is 95%, so 0.95. And of course, we're interested in the inside area. We're interested in the confidence interval. And there it is, 52.73 to 59.7. Now we're going to do this again using t-interval. So I'm going to go into stat. I'm going to go over to tests. And I'm going to go down to t-interval. So now we're doing example 9. And I'm going to use the statistics that we've got. Our standard, our sample mean is still 56. We're doing the same example again. Our sample standard deviation is 8.6. N is still 29. And our confidence level is 95%. We're going to calculate that. And out pops that exact same confidence interval, 52.73 to 59.27. It's reminding us of x bar and the standard deviation that we put in and the sample size. Okay, so here are the calculator keystrokes for 8.3 number 10. So the first thing that I did is I went into the stats menu and I loaded all the data. So there it is. And having loaded it, I can now go into the stat menu, over to tests, and down to a t-interval. I'm going to use data, and that data is going to come from L1, and our confidence level is 98%. I'm going to calculate that. So the true population mean for the IQ of famous people is somewhere between 128.8 and 162, with a 98% level of confidence.